Welcome to another deep dive. Today we're cutting straight to the chase on one of the most talked about innovations in artificial intelligence, pre-trained large language models, or LLMs. We've poured over a stack of fascinating sources, got some helpful diagrams, a historical roadmap, really all designed to demystify how these, well, incredibly powerful AI tools actually work, and crucially, how they're being woven directly into data platforms like Snowflake.
Yeah, exactly.
Huh.
Our mission for this deep dive is really to equip you with a crystal clear understanding. We're going to unpack not just what a pre-trained LLM is, but really delve into the intriguing how it learns from this incredibly diverse sea of data. And then we'll connect those sophisticated capabilities to practical, ready-to-use functions, especially within a system like Snowflake Cortex. You should walk away with a clear, actionable picture of this rapidly evolving landscape.
Okay, so we flagged pre-trained LLMs as the core topic, but for someone maybe just encountering this term, or even for those who've heard it thrown around a bit, what's the fundamental concept? What is a pre-trained LLM?
Right. Well, think of it maybe like a universal language interpreter, one that's basically read a huge chunk of the internet and more. At its core, it's an AI model that has been trained in advance on just massive amounts of text and increasingly other data types too. The pre-trained part is really the game changer here. It means instead of building a whole separate complex model from scratch for every single language task, summarization, translation, text generation, you get this single highly adaptable foundation.
Okay.
It fundamentally shifts AI development. You move from these bespoke, really resource-intensive projects to leveraging a common, incredibly powerful base.
I like that the universal language interpreter idea. It really clicks. So if it gets this like broad education first, how does that vast general understanding then get, fine-tuned for a specific job, like summarizing my emails or something?
Yeah, that's precisely where this two-stage process comes in. People often call it transfer learning.
Yeah.
So pre-training is like giving the model that incredibly broad education across text, sure, but also image context, maybe even video data. It learns general patterns, grammar, semantics, relationships between concepts.
Okay.
Then transfer learning.
Right.
That's where you take that huge pool of knowledge and you fine-tune it. You specialize it for a very specific task. Maybe it is summarizing legal documents or generating marketing copy or answering questions about a specific product manual.
Right.
And this two-stage approach, it's a key reason, probably the key reason, for the impressive, sometimes almost magical performance we see from LLMs across such a wide range of tasks.
That makes a lot of sense. But when you say diverse data during that initial pre-training, what exactly are we talking about? Can you give us a sense of the sheer variety? Is it just books and websites?
Oh, it's truly mind-boggling, the scale and variety now. Yes, textual data is foundational, entire libraries of books, news articles, web pages, code. But it also learns from things like emojis and expressions, understanding the sentiment visually associated with them.
Huh, interesting.
And yeah, increasingly, videos and other multimedia content are part of the mix. Think YouTube descriptions, maybe even sequences of visual frames in some research contexts. When we talk about diverse data, it's not just the volume, which is enormous, but the richness of contexts. By seeing patterns across everything from like Shakespearean sonnets to YouTube comments and how emojis line up with tone, the model learns incredibly sophisticated abstract representations of language and concepts.
Okay, so it's digested all of that, like you said, a digital universal library, almost. What can a model trained on that level of diverse information actually do with that understanding? What kind of predictions can it make?
Right, so once it's pre-trained, this deep understanding lets it predict things. The simplest example is predicting the next word in a sentence. That's the basis of things like autocomplete on your phone.
Yeah, okay.
But it goes way beyond that. It can infer sentiment. Is this review positive or negative? It can classify topics in an article. It can translate languages. It can summarize long documents. And in some cases, it can even anticipate the next logical visual in a sequence, like predicting the next frame in an animation or video, although that's often more complex.
Wow.
The core idea is that transfer learning lets the model apply this broad knowledge gained from massive mixed data sets to make pretty accurate, often nuanced, real-time predictions for all sorts of specific tasks.
Okay, so understanding how these models are built and what they can do conceptually is crucial. That's super clear now. Now let's connect this directly to what our listeners can actually do with this power, particularly within, their existing data setups like Snowflake. How does this translate into practical applications?
Right, and this is where things get really interesting from a data workflow perspective.
Yeah.
Snowflake Cortex is basically the mechanism for this. It brings these pre-trained LLM capabilities directly into the Snowflake platform, which means you can use them directly in SQL.
Directly in SQL.
Directly in SQL. This fundamentally means you often don't need to mess around with external API calls or build complex pipelines to move data out, get it processed, and bring it back in for many common tasks.
Okay, hold on. That's a huge. For data professionals, keeping AI functions within the secure data warehouse, that must be a massive win, right? Less complexity, better governance.
Exactly. It simplifies things enormously.
Right.
No data movement hassle for these tasks, better security, lower latency.
So can you give us some concrete examples? Like what SQL command would I actually type?
Absolutely. Let's say you have a table with customer reviews, maybe called My Reviews, and a column review text. You could just write select snowflake.cortex, set summarize review text from My Reviews.
Just like that?
Just like that. And you'd get back a concise summary for each review in the table.
Wow. Okay, what about sentiment?
Similar idea. If you have, say, social media comments in a comment column in a social data table, you could use select snowflake.cortex sentiment column from social data, and it would return a label positive, negative, or neutral for each comment. It's remarkably straightforward for these core tasks.
That is straightforward. So it's not just text sentiment then. You mentioned multimodal data earlier. Can Cortex handle things like video metadata?
Well, it can certainly work on the textual metadata associated with other types of content. So yeah, you could definitely use the summarize function on, say, YouTube video descriptions stored in a column to get a short summary of the video content or classify topics.
Okay, got it. So it works on the text about the video.
Right. And for things like predicting the next word, potentially using context that might include emojis if they're in the text, you could use something like select snowflake.cortex.complete. I had such a, as next word. And it might predict great or great time based on the patterns it learned.
That's pretty powerful, and it sounds almost too easy. Are there any gotchas? Any common limitations users should know about when using these built-in functions? What can't you do directly in SQL?
That's a fair question. It's not magic. There are boundaries. Most of these core language tasks, summarization, sentiment translation, text completion, even question answering against your text data, they can often be handled fully within Cortex using SQL. However, something more complex, like, say, analyzing the actual visual content of video, predicting the next frame from raw video data.
Ah, okay.
Yeah, that kind of task typically still requires moving outside of plain SQL.
Yeah.
You'd likely use something like Snowpark Python, maybe call an external specialized multimodal LLM API. Direct video frame processing isn't currently a built-in SQL function in Cortex.
Right, makes sense. So it's incredibly powerful for language-based tasks on data already in Snowflake, but not quite a universal tool for all types of AI on all data formats just yet.
Precisely. It's exceptionally good at bringing common, high-value language AI tasks directly to where the data lives, which is a huge step.
So pulling this together, what does this all mean for someone using Snowflake or maybe any company looking to integrate AI more deeply into their data strategy? What's the big picture impact?
I think the real revelation with Snowflake Cortex or similar embedded AI features in data platforms isn't just the efficiency, though that's part of it. It's about fundamentally changing the accessibility and integration of AI.
Yeah.
By putting these powerful language functions inside the secure, governed data warehouse, you eliminate that whole data movement headache.
Yeah.
No worries about data egress for these tasks. Compliance becomes easier, latency drops.
Yes, the data gravity problem.
Exactly. It helps solve that. It essentially democratizes these powerful AI capabilities for regular data teams. Suddenly, data analysts, SQL developers, they can leverage sophisticated AI using skills they already have using SQL commands. It makes AI a native part of their existing workflow rather than some separate specialized project. It accelerates time to insight dramatically.
That seamless in-database capability, it really does sound like a massive leap forward. But, for our listeners to truly grasp how profound this shift is, I think putting it in historical context helps. What did AI for language even look like before we got to this point? Where did we come from to arrive at Cortex and similar integrations?
That's a great point. Yeah, understanding the journey really highlights the significance of where we are now. We've come a very, very long way. If you look back, you can sort of break it down into phases. Think about the manual mining phase. maybe 1950s to 1980s. Here, we had very basic rule-based systems. The classic example is ELIZA, a simple chatbot.
Ah, yes, Eliza.
Right. It mimicked conversation using predefined rules and pattern matching, but there was no real learning, no understanding. It was clever programming, essentially. Then you move into what we could call hand tools mining, maybe the 1980s up to the 2000s.
Yeah.
This is where statistical natural language processing, or NLP, started to take hold. Techniques like n-gram models appeared.
N-grams. Okay, looking at word sequences.
Exactly. Predicting the next word based on the previous few. Better than pure rules, but they really struggled with context, with understanding the meaning beyond a few words. And building these models still required a lot of manual feature engineering, a lot of effort for specific tasks.
So very limited still. When did actual learning start to become a bigger factor, moving beyond just statistics and rules?
That really kicks in during the mechanized mining phase, say the 2000s up to around 2017. This is the era where neural networks started being applied seriously to NLP. And critically, techniques like word embeddings emerged, things like word-to-vec.
Word-to-vec, right. Representing words as vectors, capturing some meaning.
Precisely. That was a significant leap. Models could now learn relationships between words based on how they were used in vast amounts of text. But even these models often struggled with long-range dependencies in text. Understanding how a word used early in a paragraph influences the meaning much later on was still hard. The real watershed moment, the industrial refinery breakthrough, happened from about 2017 to 2022. This was driven by the invention of the transformer architecture.
Transformers, that's the key, isn't it?
Absolutely fundamental. Transformers allowed models to weigh the importance of different words across long stretches of text, really capturing context effectively. This led directly to the powerful pre-trained LLMs we started hearing so much about: Google's BERT, OpenAI's GPT-2, then GPT-3. These models offered incredibly strong contextual understanding, but they also came with huge computational costs for training, and even running them often required specialized infrastructure.
Right, the massive models needing massive resources. And that brings us pretty much up to date. What defines this current phase we're in now?
Exactly. We're now in what some might call the global gold market era, or maybe better, the era of pervasive integration and real-time AI. Think 2023 to now. What characterizes this phase? Well, first, readily available, often real-time LLM APIs that developers can easily call. Second, much better multimodal support models that genuinely understand combinations of text, images, sometimes audio. Third, more options for fine-tuning these large models on your own data, or even deploying them privately for security or customization.
And crucially,
This is where embedded AI in cloud platforms like Snowflake Cortex really comes into its own, bringing the models to the data, making them accessible via SQL or simple interfaces. Now, while this phase is incredibly powerful, it's still evolving fast. We're still collectively working through challenges like model bias, the risk of hallucinations or inaccurate outputs, privacy concerns, and cost management.
that's a fantastic overview of the journey. So boiling it down, what's the single biggest takeaway from this evolution for someone listening today? What's the core shift?
I think the key is seeing the dramatic progression.
Yeah.
We went from early phases that were extremely limited, highly manual, and didn't scale well, through statistical methods and early neural nets that were better, but still lacked deep context, to the transformer revolution, giving us powerful contextual understanding, but initially with high barriers to use. And now arriving at a phase where these advanced capabilities are becoming real-time, scalable, increasingly multimodal, and this is the critical part for enterprises tightly integrated into the platforms where their data already lives.
Right.
And Snowflake Cortex is a prime example of that final stage. It stands out because it brings these sophisticated LLM capabilities natively into the enterprise data warehouse. That dramatically reduces latency, simplifies workflows, and enables seamless AI-driven insights right alongside your core data operations. It's really about bringing the power to the data, not constantly moving the data to the power.
What an incredibly insightful deep dive. We've really unpacked pre-trained LLMs, seen how they learn from just this immense variety of data, and crucially, how that translates into practical in-database AI capabilities through platforms like Snowflake Cortex, really transforming how we can interact with information.
Indeed. It's fascinating stuff. And considering how far LLMs have come,
Yeah.
from just predicting the next word to understanding complex contexts across all this diverse data, and now seeing their native integration directly into data platforms. It really makes you wonder, doesn't it? What new forms of prediction beyond just language might become commonplace in everyday enterprise workflows when AI is truly deeply woven into the very fabric of the data platform itself, rather than being a separate layer,
Hmm.
something to maybe mull over until our next deep dive.